Going to go to the next step in polynomials in grade 10, and that is what's called factoring. Factoring is the inverse operation of multiplying. So we're going to practice by multiplying some review. So we're going to take this first term and multiply it by both terms. What do we get? We get 6x squared plus 2x. And so my question to you is, what is the GCF of your answer in A? So this might be a little bit harder for you to understand. Remember, GCF is the greatest common factor. So what can we see that's common to both? So I'm just going to write out 6x squared and 2x separately, and I'm going to write it as factors. So 2 times 3 times x, and then you can see the 2 times x. There's nothing really much I can do here. So can you see that there's a common 2 and a common x that's common to both? So that's how you find the GCF, is you can write out the factors like that. Otherwise, some people get really good at this and they can just look at it and can kind of tell. So the technique of factoring is the reverse of multiplying. As you can see in my multiplication question, I multiplied the 2x into the 3x plus 1. The factoring is now going to take the 2x out of my answer. So basically taking this answer and making it look like that. That would be the factoring process. Okay, so example 2. We are going to factor out the GCF. So if you're having trouble finding the GCF, I would suggest writing out the terms and writing out it in prime factors. So for instance, I'm just going to do for the first couple. 4 is 2 times x, and 6 is 2 times 3. So you can see that there's a common 2 that I can take out. So when I factor, I'm essentially dividing a 2 out of both terms. So if I take a 2 out of 4x, you're dividing 4x by 2, and I get 2x. If I take a 2 out of 6, I get a plus 3. So now, the nice thing about this is if you wanted to check your answer, all you have to do is multiply 2 times 2x, 4x. 2 times 3, 6, exactly what I started with. So again, 3b squared would be 3 times b, and 6b would be 2 times 3 times b. So you can see there's a common 3b. So that's what I'm going to take out now. So 3b bracket. And if I start with, something to note is if I start with 2 terms, I better have 2 terms inside the brackets. So 3b times what? And you can actually see what you're timesing by looking at what isn't circled in when you found your common factors there. So 3b times b, and then plus 2. So again, I can check by multiplying 3b times b, and I get 3b squared. 3b times 2, and I get 6b. So I'm going to say, if you get what I'm doing here, pause it, pause the video and do the rest, and then compare. Otherwise, you can continue with me going over this. So again, 5c and 10. There's no c's in common, but I know 5 goes into both of them, so I'm going to factor out a 5, and I'm left with 2c, sorry, that's a mistake. I'm left with c plus 2. Again, check. 5 times c is 5c, 5 times 2 is 10. This one might be a little harder to see, so I'm going to write it out as prime factor. So 4 is 2 times 2, n squared is n times n. 14 is 2 times 7 times n. So you can see a 2 and an n that's common. So 2n bracket, what's left? 2n plus 7. Like I said, it's easy to see if you write it out what factors are left after you factor out the GCF. However, this showing all these steps where you write out the prime factors will not gain you speed. So at some point, you kind of just get it and you can see what the common factors are taking out. So for E, it's even, so I know I can take out a 2. There's not an a common to both, so then this was 5a minus 4. Again, they're both even, so I'm going to take out a 2. There's an m common to both, so I'm going to take a 2m, and I'm left with minus 3m plus 2. Again, check your answer. 2m times minus 3m. Now, sometimes starting in a bracket with a negative isn't such a great thing. So sometimes we might factor out, even though it's not common to both, a minus 2m, and then you're left with positive 3m minus 2. So why would I want to do that? Probably if I wanted to make it into a subtraction versus an addition, things like that. So now we have trinomials. Trinomials will be factored further in a different lesson, but we're just doing GCF factoring today. So we take out a 2 because they're all prime numbers. Notice that there's an n common to 2 of the terms, but not the third term, so we can't take an n out. So then we just left with n squared plus 2n plus 3. Does that make sense to you? There's not a common n in 6, so I can't take an n out. I have to be able to take something out to all 3. Okay, next one. There's a 3 that's common to all of them, so I'm going to factor out a 3. And then I'm left with n squared minus 4n minus 3. So now you could argue for I, you could factor out a negative just to make it positive. The term leading coefficient, usually we try to have, whatever's the square as a positive. So I'm going to actually take that out. This one might be a little harder to see what the GCF is, but they're even, so 2 goes into there, but that's not the greatest. Then you go up to 4, and you can see 4 you can take out. So I'm going to take out a minus 4, and then I'm left with 3v squared, because minus 4 times positive 3v squared is minus 12v squared. And then minus 4 times minus 2v, and minus 4 times plus 4. Let's check our answer. Minus 4 times 3v squared minus 12v squared, minus 4 times minus 2, so minus times minus gives me the positive 8v, and then minus times a plus gives me the minus 16.